So today, we're gonna talk about. So by the way, we're now in the new chapter. So chapter 2 is all about deductive reasoning. Anybody know what that is? What is that? Yeah. If and then. Not really. Look at what's inside the parentheses. Shh. Yes, sir. Yeah. Logical sequence. Okay, when you reason something, you're doing it in logical sequence. That's called deductive reasoning. What's a nice example of deductive reasoning that we'll be doing in geometry throughout the whole year? Yeah, proofs. When you do proofs, okay, like the 2-column proofs, right? We'll be using deductive reasoning to do these proofs. We're going to be using logical sequence. Is that okay? All right. So this whole chapter 2 is about deductive reasoning, logical sequence, and it's of course going to show you how to do proofs. Okay. But before we do proofs, we're going to learn something called if and then statements and its converses. Okay. So that's what the 2.1 is about: if and then statements. What do you think if and then statement would have? Which 2 words do you think if and then statement would have? Yeah, if and then. Yeah, okay, that's good. So if and then statements have if and then in them. Oops. Okay, so they're also called conditional statements or conditionals in short. Okay, so write that down. If and then statements are called conditional statements, or sometimes called conditionals for short. Okay, so I'll wait. So let me give you a conditional statement. I will give you $1 if you give me $100. That's bad for you, right? But do you see why it's called conditional statements? Why is that called? Why do we call this if and then statement conditional? So if you give me $100, I will give you $100. If you give me $100, I'll give you $1. Why do you think these are called conditional statements? Yeah.
Because the if part is like conditions that have.
Exactly. It's just, yeah. I'll give you $1. What's the condition that has to be met? If you give me 100. Okay. So, all right. So these if and then statements, you're right. There are statements that comes after if, and then there's statement that comes after then. Does anybody know what we call the statement that comes after if part? It starts with H. You learned this in summer school. Yes, sir. You got it. It's called the hypothesis. Hey, then what about the statement that comes after then part? What do you think we call that? It starts with C. Starts with C. Yes, sir. Conclusion is correct. Okay. So I said, if you give me $100, then the conclusion, I'll give you $1. Oops, sorry. Okay, there you go. Right. So, the condition is the hypothesis, right? If that's met, I'll do the conclusion. By the way, we use letter P for hypothesis. Anybody want to guess which letter we use for conclusion? Yes, sir. Q. Very good. Why do you think they use Q? Because Q comes after P. Okay. Very good. Okay. So write that down. I'll wait. Okay. Oh, why do they use P? They just use that a lot like that. Okay. I don't know. So for hypothesis and conclusion, they use P and Q a lot. Yeah. Sorry, I don't know why. So the hypothesis part. Do you think if like on the test I ask you in if and then statement in a conditional, if I ask for the hypothesis, would you add if into that statement? Like, would you add the word if? No, you wouldn't. Okay, it's the statement after if. Okay, so don't include if. If I ask you on a test, okay, like for example the one I gave you, if you give me $100, then I'll give you $1. What's the hypothesis part? Yeah, is it if you give me $100 or is it just give me $100? Give me 100. Yeah. So don't use if and then in parts. So for the conclusion, do you include then in there? No. Do you understand? Some people do that and that's wrong. Okay, just it's the part after if is the hypothesis, part after then is the conclusion. We'll do some examples like that. Okay, makes sense. All right, now Converse. How many people have heard of Converse? Okay, not the shoe. Okay, yeah. Some of you wear not that Converse. In terms of this conditionals, anybody know what a converse? How do you? So it turns out if you have a conditional statements, you could always write its converse. How do you do this? How about Justin? What do you think? You're exactly right. He's saying all you have to do is replace the hypothesis and the conclusion, then you get a converse. Okay, but not literally. I'll show you what I mean by that. So write this down. Converse of conditional is formed by interchanging the hypothesis and the conclusion, but not word by word. I'll show you what I mean as we do an example. So write this down first. Okay, so for example, if P then Q, that's a statement, right? That's a conditional statement. Of course, converse will be if Q then P. Okay, so let's do an example. It says the number is divisible by 3, then it is divisible by 6. By the way, is this true? A number is divisible by 3, then it is divisible by 6. Is this true or false? It's false. Okay. So will all the statements be true? These conditional statements? No. They're not going to be always true. Sometimes it'll be false. Sometimes. Anyway. So let's write its converse. So to write its converse, can I do this? It says you just replace the hypothesis and the conclusion, right? So watch what I'm going to do. Can I write it this way? If it is divisible by 6, then a number is divisible by 3. Can I do that? No, you don't want to write it that way. You don't start the sentence with if it is. You don't know what it is. You know what I mean? So how would you? So like I said, that's why I'm saying you don't just replace the word by word. How would you change it so it actually makes sense? You learn this in English, right? You don't just do that. How would you? What did you, Nicholas? How do I do that so it makes sense?
If the number is divisible by 6, then it's
Exactly. So that's what I'm looking for. You guys know what I'm talking about? You understand what I'm talking about? So you don't just replace them word by word. You have to make the statement has to make sense, right? You don't start with it. Okay, you have to tell me what that is first. By the way, is this statement true?
yes.
It's converse? Yeah, it's kind of interesting, right? So if you write the statement, the conditional statement, and if you write its converse, this converse happens to be true, right? Does this work every time? Do you think if I have a false statement and write its converse, it'll be always true? No, it just depends on what sort of statement you have, right? What about this? If you have a true statement and you write its converse, do you think it'll be true? No, it depends, right? It depends on the statement. Sometimes it will be, sometimes it won't. It depends on what kind of statement you have, right? So it doesn't guarantee. Just because you have a true statement, right, it doesn't guarantee you that the converse will be true or false, okay? It depends. Does that make sense? Okay. Any questions? So like I said, just because the statement is true, does it necessarily make the converse true? No, it doesn't. It depends, right? Okay, so now write this down. An if and then statement, or conditionals, is false if an example can be found for which the hypothesis is true and the conclusion is false. So if you want to show that a statement is false, you just need how many examples? One. You just need one. If an example can be found for which the hypothesis is true and the conclusion is false. By the way, what do we call this example? It starts with C. We talked about this, I think, once or twice. What do we call an example that shows that the statement is false? One person? 2? 3? How about Hannah? Counterexample is correct. So, but what does this mean when they say the hypothesis is true and the conclusion is false? Doesn't it have to be false for everything or something? Why do they say the hypothesis is true and the conclusion is false? Sorry, people are still writing. Let me just wait. Okay, I want you to think as well. Don't just... Alright, so... Go ahead, keep writing. I'll wait. So, Austin's question is right. What do I mean by hypothesis is true and conclusion is false, right? Right? So let's go back to that statement that we had before, which was that first statement, that statement that wasn't true. If a number is divisible by 3, then it is divisible by 6. Is this statement true or false? False. Somebody then give me, because we just said you could show that the true statement is false by coming up with one example, right? A counterexample. Who can give me a counterexample? Yes, sir. One person knows? Two people? 3, 4, 5? Okay, a lot of you. Who haven't I called today? How about I haven't called Josh. 3, right? Is 3 a good counterexample? Yeah, look. But didn't we say if it's a counterexample, it has to be true for the hypothesis but false for the conclusion? Is it 3 divisible by 3? Yeah, see, that's true. But is 3 divisible by 6? No. We kind of know this already, but the way we say it, it sounds sort of funny. But if it's a counterexample, it has to meet that first condition, right? If you're going to give me a counterexample, right? If you're going to give me a counterexample, can you give me like 2 as a counterexample? No. Why not? Yeah, 2 is not divisible by 3. Does that make sense? That's what I'm trying to say. You get what I'm trying to say here? So what else could be a counterexample? There could be many. Yeah. 27? Yeah. 6? Wait, 6? 6 would not be a good counterexample.
9 with 9.
9, yes, 9 would. So 9, 3 is divisible by 9, but, right, 6 does not go into 9. Does that make sense? You all get what I'm trying to say? So that's what we mean by, if you're going to give us a counterexample, like I said, this is something you already knew. But the way we say this, it may kind of throw you off. But the hypothesis has to be true, right? The first part. Yeah. But then the conclusion is false. That's how you get a counterexample. So write this down also. It takes only one counterexample to disprove a statement. So it is really easy to prove that something is false. However, it takes a lot of work to actually show a statement is true. That's where the proofs comes in. Okay. So it's really easy to show that the statement is false. You just have to come up with one counterexample. That's it. Even if it works every single time except one case, guess what? If it doesn't work for that one case, the statement is then false. Okay. It may work like 1 million times, right? Every time, except for that one case, it's false then. Okay. So if you could come up with one counterexample, the statement is false. Okay. So it turns out you don't always have to start with if and then for conditional statements. Okay. So conditional statements are not always written with if first. Okay. You could actually use different words so that the statement is conditional. I'm going to show you some examples. So write this down first, and let's go through these. Okay. So here, like, if P then Q, right? So there's other ways. So of course, if you have if and then statement, it's conditional. You could actually use this word implies. So you could just write P implies Q. Okay. If you see that word implies, it is still a conditional. Okay. Another word you could use, actually 2 words, only if. So if you could write P only if Q, they all mean the same thing. It's just like if you wrote this, P only if Q, it's the same as if P then Q. Okay. So sometimes you will see that people use different words other than if and then. So for example, if I had this conditional, if x squared equals to 25, then x is less than 10, can somebody rewrite that conditional statement using implies? What would you do? Michael? You got it. So you just have to replace, right? In place of P, that's the hypothesis, right? You just write the hypothesis. Right, x squared is equal to 25 implies x less than 10. Easy? Yeah, it's easy. Okay. What about if you wanted to use only if? How would you, Kevin? How would you write that using only if? Yeah. Exactly. Yeah. Okay, good. Easy, right? I'll wait for you to finish up. Right? Okay. It turns out there's actually one other way, but this method is actually simple, but people mess up the most in this. So you could actually write these conditional using just one word. If. I actually used this before in the very beginning, and we use this a lot in everyday life, right? In real life. QFP. Now, anybody see something sort of different than This one is sort of different than all the other three. And I even put a star here. What do you see? Nicole? Q is first. So, Samantha, what kind of mistake do you think people will make if I use the word if only? I mean, not if. Just it. Yeah, people might see that, look, all the other cases, whatever that comes first is your what? Hypothesis, right? But if I use if by itself like that, what comes first? Conclusion. And I actually use this. Remember I said, I'll give you $1, what? If you give me $100, right? Which one was the hypothesis? If you give me $100, right? Does that make sense? You see what I mean? So we use this a lot in our, actual life. So please keep that in mind. And so this is, like I said, I cannot tell you how many times I've seen people mess up on this. How would you write this? For this example, if x squared equals 25, then x is less than 10. Using if by itself here. How about, who could tell me how to write this one? Oh, actually, Young, what do you think? Exactly. Please write the conclusion first and then hypothesis. Some person said, oh, do you know if you see if by itself, like this one has only if, right? That doesn't work. But if you have if, the statement that comes after if is your hypothesis. You could think about it that way. You see how, so you could think about it that way if you like, but, for this one, please remember that it's switched, okay? All the other ones, they're same order. This one, you gotta switch the order. Okay? So we'll do some examples that shows you this in a minute. See if you remember, okay? Okay. Go ahead and write it down if you're not done writing. Okay. Brandon, is it true? Is it possible for a statement, conditional statement to be true and its converse to be true? No, you don't think so? Actually, it's possible. Okay. Well, is it true for every statement? No. But is it true for some statement? Yeah, okay. So for some statements, the conditional will be true and also its conditional may be true. Okay. If that happens, we could actually combine them into. So it says if a conditional and its converse are both true, then they can be combined into a single statement by using the word if and only if. And when you do that, that statement is called, since you're combining two of them into one, like like bicycle, what's it mean? Two, right? Bi, right? So it's called biconditional. Okay, so write that down. I'm gonna do an example in a minute. So I'll wait. If a conditional and its converse, so some statements, some conditional statements, okay, if you write its converse, the statement and the converse will be true. And if that's true, you could actually combine them into one statement using this word if and only if, okay? So like this. Hypothesis, P, if and only if, Q. Okay, so that's what you do. So if you see a statement that looks like this, P, if and only if Q, then you know it's a biconditional, then you know that it's conditional and its converse are both true. Does that make sense? Let's do an example, but before we do an example, we'll do an example for something else. Watch this. This is a fact. Every definition, turns out, can be written as a biconditional. But that's a fact, okay? So let's do this exercise with a definition. So I'm going to give you a definition for congruent segment. You guys remember what we talked about? How do we define congruent segments? Segments that have? Yeah. Same length, okay? Equal length, right? Same thing, okay? Equal length. So, can you guys write this then as a biconditional using that if and only if part? By the way, which one of these is a hypothesis? You could think of this well, sort of funny for definition too. Hypothesis what? Is for this definition? What would be the hypothesis for this definition? You think equal length is the hypothesis? Yeah. Congruent segment is, whatever comes first is the hypothesis. Then whatever comes after is the conclusion, right? So knowing that, go ahead and write this as a biconditional using if and only if. Because this is a definition, and we just told you that definition can be written as a biconditional. I'll give you time. And talk with your group and so forth. That's okay. Yeah, question?
Wait, so the first part of the sentence is always the hypothesis?
Unless you have if in the middle or something like that.
Oh, okay.
But definition is sort of kind of, anyway, okay, go ahead, just try, see if you could write this. Okay, so who could tell me? So some of you are saying, you can't do it. Well, I told you, you could. Okay, so how do you do this? Who has, I haven't, Esther, what do you think? Yeah. There you go. There you go, right? Segments are congruent if and only if their lengths are equal, right? There you go. So you have a biconditional, right? So this statement, right? For this statement, it's conditional and its converse are both true, right? You could also say if the segments have equal length, then if the segments have equal length, if and only if the segments are congruent, or you could say it like that way too, because since right, conditional and its conditional and the converse are both true. But let's just keep the same order as is written. That's what I meant by definition. We'll keep the same order. Whatever comes first, we'll take that as the hypothesis, and whatever comes after is the conclusion. Yes, sir?
Can you have like a converse of a biconditional?
Yeah, you can. And then there will be, it's going to be true also, right? Because by definition, biconditional, its converse and its conditional are both true. Does that make sense? So how would you, what would the conditional for this biconditional be? Somebody tell me a conditional for this biconditional. Using if and then. Jason?
If a segment's length is, if two segments' lengths are equal and
Using the first statement as the hypothesis, what would that be? Hannah? Yeah, if segments are congruent, then their lengths are equal, right? That would be, what would be the converse of that? Yeah. If the length of the segments are equal, then they're congruent, right? And if you combine them both, this is what you get. You get this biconditional, right? Segments are congruent if and only if their lengths are equal. Yes?
So you just switch their places in the sentence
For what?
for a converse?
Yeah, for converse, all you have to do is, right, change the hypothesis and the conclusion. That's all. Are we okay? Are we good? Let's do an example here. Let's see if you guys remember what I just told you. Okay, here's the example. I would like you to identify the hypothesis and the conclusion by underlining the hypothesis and put double lines underneath the conclusion. Now here are the three statements. Example 1a, if a plus c equals to b plus c, then a is equal to b. Second one, r equals to s only if r plus n is equal to s plus n. And the last one, I have a star on there. I don't know why. Hint, hint. R plus n equals to s plus n if r equals to n. R equals to s. Okay, go ahead and underline the hypothesis and put double lines underneath the conclusion. Okay, so I'll wait. You may talk to your group. That's fine. Help each other out. That's fine. Okay. Tony, can you help us to do number 1 here? Which part is the hypothesis in example 1a?
A plus C equals B plus C.
You got it. Okay, you're paying attention. Okay, so if that's true, then which part is the conclusion? Of course, it's going to be class. Yeah. All right, number 2. How about I would like to ask Naomi. Can you tell me the hypothesis on this one? On B. You got it. R equals S, and of course, class. What's the conclusion?
R plus n equals s plus n.
Perfect. Okay. Last one. Emin, can you tell me the hypothesis on this one? R equals to S. Isn't it the first part? Why did you say the second part? You're right, actually. Yeah, it says if by itself. Remember, that's the one that they switched? How many people got this right? So it turns out, yeah, raise your hand. How many people got this right? Oh, okay, how many people forgot? Okay, don't make the mistake then if you did. Okay. So if you have if by itself, right? Whatever comes first is your what? Conclusion. And then remember I told you I'll give you $1 if what? You give me $100. Okay, see? So it was switched. Any question? Are we good? Yes? All right, good.